Greetings. In this video, I'm going to show you another reactions involved for alkenes, but this time it is not related with addition reaction. As you can see here in this learning outcome, we are going to learn about the reactions of alkene with ozone, followed by zinc, water, and this is also known as ozonolysis. And then the second one is the reaction of alkene with hot acidified potassium permanganate. So let's proceed. Now I'm going to explain the first one, which is what we call as ozonolysis. So basically ozonolysis is also known as oxidative cleavage reaction. This is not this is not addition reactions, but it involves the oxidative cleavage. For this reaction, the reagent needed is first ozone. So what will happen? Alkene will react with ozone first to produce the first intermediate. And after that, the intermediate will react with zinc and water. And the product of this reaction is carbonyl. So what exactly happened? As you can see here in this one, the double bond is broken to form the carbonyl groups, and this ozonolysis reaction can be used to locate the position of double bond in alkene. So I will explain to you about it later. Now let's proceed with the example. So here we have, this is our alkene, and if we name it, we are going to get this one is 2-methyl propene. Okay. Now, what you have to do exactly is actually first you have to write it like this. Maybe you wonder why we have to put 1 and 2. Okay. Basically, the reaction start with number 1 first, which is alkene react with ozone. And after that, the intermediate will react with this, the number 2. So we put it 1, 2 to show that the reaction is actually separate. However, we are not going to write what is the intermediate. We directly write the product of this reaction, and that is why we just write like this directly 1 and 2. Okay, so again, you have to write 1, ozone, number 2, zinc with H2O. So let's take a look. How can we get the answer? Okay, for this one, for this, we are going to get this product. Yeah, we are going to get 2 products, definitely. Okay, so this is the product that you are going to get. If you wonder how we get this product, so I will repeat once again. Okay, so this is a tips from me. Now, if you look at the second point just now, this is the third point. The double bond is broken to form carbonyl group. So we are focusing on this double bond. Okay, so what will exactly happen? This double bond will be broken. So usually I will show student, okay, it will break something like this. Okay, when it breaks, so it will give us product this. Okay, so say this carbon has like half part of the double bond, and then we have CH2, so I expand it, CH2. So this carbon also has another double bond. So as you can see, it's broken here. And each of them will get half of the double bond, something like that, okay? Okay, next, after you break them, what you need to do is just you add the O. Yeah, you just add the O. So as you can see, we have carbonyl group, okay. This is carbonyl, okay, exactly. This is ketone, because it is, if you see, this C is connected to C and another C, so it is ketone. And this one is actually, this one we call as methanol, because it only has, overall in this structure, it only have one one carbon that connected with two H. So this is methanol. Okay, so basically, again, the double bond broke, and then you just add O. Okay, let's take a look at second example. Now, in this second example, as you can see, we have what we call a cyclic ring. So if you remember, I said the double bond will be broken. So it would be like this, breaks here. And what will happen? Is it going to get two products? Okay, no, the answer will be no. The product that we are going to get is this. You can just copy back the drawing. Okay, so the double bond is around here, right? Okay, so this is your CH3, and here we have CH3. Now, basically, the double bond is here. So when it is breaking up, it actually forms like this. The one of this carbon will have one double bond, and this carbon will have another double bond. Okay, it's like terbuka lah. Okay, and then after each of the carbon get the double bond, just add O here. Okay, just add O here. All right, so I repeat once again. I just repeat the same thing. 1, 2, 3, 4. We have our CH3 here. We have our CH3 here. So each of this carbon will get half of the double bond. Okay, here. Or maybe if you don't feel like you want to draw it there, you can also draw it here. Okay, and then just add O. So you have this structure. All right, so just break it up and add O. Okay. Now let's take a look at the second oxidative cleavage reaction. This time we are going to react this alkene with acidified potassium permanganate, and we have to heat it. So you can use two reagents. Either you use acidified potassium permanganate or acidified potassium dichromate. So this one is why I keep saying acidified, because this potassium dichromate or potassium permanganate is being added with acid. So what will actually happen here? Now, I want you all to know that whenever you see these two reagents, this is what known as strong oxidizing agent. Now, unlike what happened in ozonolysis, where the double bond will be break and you're going to get the product, whenever you react this alkene with potassium permanganate or potassium dichromate, if the product that you get here can undergo oxidation more, then it will be oxidized more. So I'm going to explain more about this. Now, I will directly go to the example here. Okay, in this example, we have this alkene, as you can see here. Therefore, the double bond will be break, and you're going to get this. you're going to get this. And then, as usual, yeah, you are going to add O here. All right. So let's take a look at this product. Now, this product has carbon double bond that is connected with one carbon and another carbon. This is also known as ketone. Okay, this is also known as ketone. And then, if we look here for the second product, as you can see, the C double bond O, the C double bond O is connected to one carbon and one carbon. So this is also a ketone. Now ketone is a substance that cannot undergo further oxidation. So usually we're going to write it like this. We're going to write it like this. Okay, this is the symbol of further oxidation, means the reaction will undergo further oxidation lah, more oxidation. But ketone cannot be oxidized, so yeah, there will be no next product produced or formed. So it will stop here. Okay, so it will stop. So that's why you will only get ketone. Now let's take a look at second example. This one. Now in this second example, okay, what will happen? The bond will break here as usual. So we are going to get something like this. So you know this, the tips, right? You have to add O here. All right. Now let's take a look at this. This is what we call methanol. Okay, methanol, okay, it can undergo oxidation. Can undergo further oxidation to produce CO2 and H2O. Okay, CO2 and H2O. So how can it happen? Okay, look at this carbon. This carbon is attached to hydrogen. Okay, it's attached to two hydrogen. So what will happen? These two hydrogen, okay, if I can draw it, where can I draw it? Okay, maybe I can draw it here. Okay, this. Okay, so what will happen? The carbon, the H will eventually be added with O, and this one also O, and yeah, like this. The H will be added with O. But this is not a stable product, okay? This is not a stable product. So what will happen? It will break again to get stability. So basically, this will break into H2O, and this will break away CO2. And that's why you get this. Okay, that's why you get this. Okay, and this one, this is aldehyde because we have carbon, the C double bond O, attached with one hydrogen and carbon. Okay, so since we have one H here, so this one will undergo further oxidation to produce OH. So the H eventually will be added with O and this one. Okay, so this is aldehyde and this is carboxylic acid. Okay, this is carboxylic acid. So before I give you what is the final answer, can you please write this first, or you can take photo first? Okay, now. So as now we know that the final answer is this and this. So in exam, you don't need to write all this. Okay, you don't need to write all this. Instead, what we need to write is, okay, let me address first. The only thing that you need to write is the final answer, which is, just write CO2 plus H2O, which is the product from this. And at this side, C double bond O, CH3. So H, you just add O, H here. Alright, so this is the final product that you have to draw or to write. Alright, so let's proceed with the third example. So this is also the same. It will break here. So what will happen? This is CH3 and then this is CH3. Now how about if we just get this one? So as we know, this carbon contain 1 H, and this carbon is already full, 1, 2, 3, so it has no H. So when this is break, okay, when the bond or the double bond is breaking up, so this one will get, this carbon will get one half double bond, and also this one will get half double bond. So you're going to add O, this one you're going to add O, but this is the carbon with 1 H. Okay, with 1 H, right? So this H can be oxidized, which is to become OH. But for this carbon, 1, 2, this is also carbon, this is also carbon, so this one cannot be oxidized. This side cannot be oxidized. So this is the answer that we get. If I can refine it, okay, if I can refine the drawing, you are going to get O, CH3, double bond O, and CH3. So this is the refined drawing. Okay, so there you go. The oxidative cleavage involving potassium, acidified potassium permanganate or potassium dichromate. So if I can make an what we call if I can help you to make with the conclusion about ozonolysis and oxidation, okay, in alkene. So here's what I can say. Okay, now we start with ozonolysis. Okay, for ozonolysis, our reagent needed is, you have to write it like this: oxygen, and number 2, we have to add zinc with water. Okay, so what will happen? Okay, what will happen? Can say that, for example, we have this structure CH3 double bond, CH3, okay, with it undergoes ozonolysis, which we're going to write like this. Okay, remember you have to write 1, 2. Okay, so you know it's likely it's going to be breaking up here. So we are going to get plus okay, that's it. So it stopped there. So we got this. This is our product. Okay. Yeah. This is our product. So this is ozonolysis. But we want to talk about oxidation. Okay. Oxidation. We have to write it like this. Either you're going to use KMnO4, H plus, heat. Okay, this is how we write it. Or okay, this is dichromate, potassium dichromate. Okay, we are going to write it either like this. So what will actually happen? So I'm going to take the same example. Okay, this one. Right. So we know that you're going to get something like this. Okay, but it will not stop there because, like I told you before, this is a strong oxidizing agent. So what will happen here? This structure will undergo further oxidation to produce this. But this one, no. Okay, if it undergoes oxidation, okay, since this is CCC, it's a ketone, so there will be no more oxidation, all right? Which means ketone can undergo oxidation. Okay, so there you go, the difference between ozonolysis and oxidation.